students, welcome back to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are going to solve last 10 years of questions from the chapter Chemical Bonding and Molecular Structure. Okay, so if we consider from last 10 years, it is very difficult to gather 30 questions from there because from PU1 there is very less weightage. Okay, so that is why what I have done is I have also combined the previous year questions of Comet K. So in this one video, you will be getting the previous year questions of KCET as well as of Comet K. Okay, so now you have to see the question, try to answer those questions, and then you have to check your solutions. Okay students, so let's get started here. And one more thing, you can join our WhatsApp channel. The link of the WhatsApp channel is there in the description section of this video, so you can get access to all our notes and mock test solutions, everything in our WhatsApp channel. Okay, fine. So coming to the first question here, that is on your Lewis structure. Okay, and this question was a KCET PYQ of 2017. Which of the following is the correct electron dot structure of N2O molecule? Now what happens here, if you see that we have for electron dot structure, the basic rule is that 8 electrons should be there, the octet rule should be satisfied, right? Now if I see the first molecule here, the first element here and the first element here, okay, so here the octet rule is not satisfied, right? So that means what? These two options we can eliminate. Now if you compare here, all the atoms, 8 valence electrons are there, here also 8 valence electrons are there. Okay, so now what we can do is, if 8 valence electrons are there, then what is the criteria? How can we decide between A and D? You need to check the formal charge. Okay, how can we check the formal charge? See here, for option number A, if I calculate, the structure is like this. We have N, double bond N, double bond O. Okay, and then here I have 2 electrons, 4 electrons, and here I have 4 electrons, right? Okay, now let me calculate the formal charge of N1. Okay, this is N1 and this is N2. So now I have total valence electron is 5. Okay, 5 minus non-bonding electrons are 4, and then we have 4 by 2, so it is minus 1. Now if you see N2, okay, that is we have 5 minus 0 minus 1, 2, 3, 4, 5, 6, 7, 8 by 2, and that is equal to plus 1. Now if I calculate oxygen, okay, so here valence electrons are 6, non-bonding electrons are 4, and bonding electrons are 4 by 2, right? 1, 2, 3, 4 by 2. So I'll get here 0. Clear? So if I want to write the formal charges, minus 1, this is plus 1, and this is 0. Okay, we got for option number A. Now if I want to calculate for option number D, okay, so the elements here are N, triple bond N, okay, then I have O, and I have 6 electrons and I have 2 electrons here. Okay, now for N1, N2, so if I want to calculate for N1, so it will be 5 minus 2 minus 6 by 2, so I'll get how much? It will be 0, right? Then if I want to calculate for N2, it is 5 minus non-bonding electrons are 0, then 1, 2, 3, 4, 5, 6, 7, 8 by 2, so that is equal to plus 1. Next, if I want to calculate for oxygen, it is 6 minus 6 minus 2 by 2, right? So it is equal to minus 1. So 0 plus 1 minus 1. So this one, if I want to write the charges, it will be 0, this is plus 1, and this is minus 1. Right? So now if you see, both the structures are having almost like N, the central N is having positive 1 in both the cases. Negative charges there on nitrogen here and negative charges there on oxygen here, right? Now if you compare the stability, the negative charge is more stable on the higher electronegative atom, right? So that is why what I can say that minus 1 is more stable on this oxygen. Okay, so that is why the correct answer for this question will be option number D here. Okay, now moving towards the next question on formal charge. The formal charge on the central oxygen atom in ozone. Okay, so again this is a previous year question of 2020. Okay, so now if you see, we have oxygen, we have like this, and we have ozone. So I can do like this. Oh sorry, the structure. Yeah, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So its octet is satisfied. Here also octet is satisfied, here also now octet is satisfied. Central oxygen, if I want to calculate the formal charge, okay, so it is 6 minus 2 minus 6 by 2, right? So I can get this one as plus 1. So the correct answer will be option number C here. Next, question number 3. This is also from the concept of ionic bond. Okay, HCl gas question was asked in 2016. Okay, HCl gas is covalent and NaCl is an ionic bond. This is because. So you should know that for ionic bond, the electronegativity difference between the two atoms should be 2.1 or greater than that, right? So in case of H and Cl, it is less than 2.1, that is why it is a covalent bond. So the correct answer is option number D here. Okay. Next, question number 4. Among LiCl, BeCl2, BCl3 and CCl4, the covalent bond character varies as. Okay, so we need to find the covalent bond character. Okay, so now this question was asked in 2020 Comet K question. It was based on Fajan's rule. Okay, so what does the Fajan rule says that if the cation, okay, size should be small, okay, and anion should be large. Okay, here the charge should be more. Okay, this implies that the bond is covalent. Okay, so now among LiCl, BeCl2, BCl3 and CCl4, these are all cations, right? Now if you see along the period, lithium, beryllium, boron, carbon size is decreasing, right? So that means smaller size, more covalent character. So carbon will have more covalent character, also it has having higher charge, right? +4 charge. So CCl4 will be highest. So we can eliminate these one option. This is also CCl4. After that, if you see lithium, beryllium, boron, carbon. So after that boron should come. So here also boron, here also boron, here also boron. Okay. Next beryllium. So here also, here also. Okay. All the options are given same. Okay. The question is, okay, I'll tell you the answer here. Okay. So it should be like LiCl2. LiCl, then BeCl2, then BCl3 and then CCl4. Okay, so I think there will be, okay, this is wrong here. Okay, so we can eliminate this option. Okay, this is also wrong here, we can eliminate this option. So this is the correct order, option number D here. Okay. Next, the charge to mass ratio of a cation determines its polarizing power. Which one of the following sequence represents the increasing order of the polarization of the cationic species? Okay, so if question was asked in 2017, again Comet K, Fajan's rule question, smaller is the charge, smaller is the size of the cation, more will be the polarizing power, or more is the charge, more is the polarizing power. Now if you see here, we have first potassium, okay, then we have beryllium, okay, then we have magnesium and then we have calcium. Okay, now what happens if you see down the group? Okay, down the group what happens, here the size is decreasing and here the size is increasing, right? The least, or you can say the smallest size will be of beryllium. So definitely the polarizing power of beryllium will be maximum. Okay, why? Because it is the smallest cation, right? Smallest cation and it should have higher charge, right? So definitely, and potassium should be least, definitely, because it is having less charge. So that is why correct answer is option number D here. Okay. Next question is on dipole moment. Which of the following possess net dipole moment? 2019 KCET question. So if you know, BF3 structure is like this. Okay. BF3 was sp2 trigonal planar. Okay. Trigonal planar. So if it is trigonal planar, then what will happen here? The net dipole moment will get cancelled out. Okay, so this is non-polar. Next, if you see BeCl2, okay, here also the net dipole moment cancel out each other. So that is why this is also not the correct answer. Carbon dioxide, if you see here also sp hybridization, net dipole moment is cancelled. The correct answer here is option number A. Okay. Next, which of these represents the correct order of their increasing bond order? Okay, increasing bond order. Okay, so now this question I'll be solving later. I have also discussed this question again, so we'll come back to this question once again. Okay, for now I'm leaving this. Okay, now this question is question number 8. Bond angle in pH4 plus is more than that of pH3. This is because, so if you know the structure of pH3, so these questions are from your bond parameters. Okay, pH3 is having a lone pair and pH4 has no lone pair, right? Okay, so now pH4 has no lone pair, so what will happen? This one is a tetrahedral structure and this is pyramidal structure, right? Due to this lone pair bond pair repulsion, there is the bond angle decreases. So the correct answer is lone pair bond pair repulsion exists in pH3. Now let us see question number 9. Pick the incorrect statement among those given below. Okay, so multiple covalent bonds are shorter than single covalent bond between the same set of atoms. Yes, this is correct. When you have multiple bonds, the bond length decreases. Next, bond strength varies inversely with the bond length. Yes, this is also correct. If bond length is more, bond strength is less. If bond strength is more, bond length will be less, right? The bond order of isoelectronic species are same. Yes, this is also correct. Bond enthalpy increases with the increasing bond length. So let us understand this one. See, bond enthalpy, okay, bond enthalpy means the energy required to break a bond is proportional to bond strength. How strong is the bond? If bond strength is more, then definitely we will require more bond. Then it is 1 by bond length. Okay, so if bond length is more, bond strength will be less. Bond strength is less, bond enthalpy will be less, right? Bond strength is more, bond enthalpy will be more, bond length will be less. Okay, so you can see here bond enthalpy increases with the increase in bond length. So if bond length is increasing, bond strength will decrease, bond enthalpy will also decrease, right? So that is why this is an incorrect statement. Option number D is the correct answer. Okay. Next, bond order in nitrogen molecule is, so if you know nitrogen molecule exists like this, right? Okay, so bond order is 3, option number C here. Next, questions are from VSEPR theory. Which of the following pairs contain 2 lone pairs of electron on the central atom? So this is a 2019 KCET question, 2 lone pairs. Okay, so now if you see NF3, NH3, they have only 1 lone pair, right? So we can eliminate this option. Now water has 2 lone pairs. If you know the structure of water, right, this is water, so it can be the answer. And in SH2 also it has 2 lone pair, this also can be the answer. Now let us check I3 plus. So if you 3 I3, we have 7 3s are 21, then 20 valence electrons. Okay, so next we have I, okay, I and I. So we have here 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. So this is the structure, and you can see 2 lone pairs are there on the central I also, right? So that is why the correct answer here will be option number A. Okay. Next, question number 12 again is from the VSEPR theory. Which of the following structures of a molecule is expected to have 3 bond pairs and 1 lone pair of electrons? 2017 question. 3 bond pairs and 1 lone pair. So it is sp3 hybridization, 3 bond pair, 1 lone pair. So if there is no lone pair and sp3 hybridization, the shape is tetrahedral. With 1 lone pair, it is pyramidal. Okay, so the correct answer here is option number D. Next, the pair of compounds having identical shapes for their molecules is, so this is 2015 KCET question. You have identical shapes. Okay, so now if you see CO2 is linear, SO2 is bent, so we can eliminate this one. SF4 is your seesaw shape and CH4 is tetrahedral, we can eliminate this one. Okay, next if you see BCl2 and ClF3, okay, ClF2, so this is BCl3. Okay, now if you see this one, these structures are also not having similar shape, we can eliminate this one. The correct answer for this question will be option number C, that is XCF2 is linear, ZnCl2 is also linear. Okay. Next, question number 14. In which of the species having sp3 okay, in which of the species have sp3 following pair both hybridization? Okay, so both the pairs should have sp3 hybridization. Which one you have to find out? So this is Karnataka NEET 2013 question also, and it was asked in Comet K also. So now if you see, you have sp3 hybridization, bf3 sp2, right? This bf3 sp2, so we can eliminate this option. NF3 and H2O, yes, BeH2 again is sp hybridization, so eliminate this one. Option number B is the correct answer. Now how am I able to solve these type of questions very fast? Because I have remembered all the structures and their shape and the examples. So that is how you should remember for all the types of different examples which is given, like one lone pair, two bond pair. These all categories examples should be learned, so that immediately, very quickly you can solve this question. You do not have to find out the structure at that point of time. Okay. Next is 15th question from hybridization 2020 question KCET. The percentage of S character in the hybrid orbitals of nitrogen are respectively. So if I see first NO2 plus, okay, total valence electron is 5 plus 6 minus 1, right? So 12 plus 5, 17 minus 1, 16. So I have N. Now I want 16 electrons, so I'll make like this, okay, and octet should also be satisfied. So I'll put like this 1, 2, 3, 4, 5, 6, 7, 8, okay, then 9, 10, 11, 12, 13, 14, 15, 16, okay. Now if I see all the octets are satisfied, so I will draw the structure like this, okay. So we have 1, 2, 3, 4, 5, 6, 7, 8, 8, and here also 8. So now what is the hybridization here? sp hybridization. So sp hybridization means S is 50% and P is 50%. Okay. So that is why the correct answer here is option number B. Okay. Next question number 16. The state of hybrid orbitals of carbon in CO2, CH4 and CO3 2 minus respectively is. So if I have CO2, okay, so you can see there is total 2 sigma bonds, and 2 sigma bonds means sp hybridization, right? So that is option number C. You should remember 2 sigma bonds is sp hybridization, 3 sigma bonds is sp2 hybridization, and 4 sigma bond is sp3 hybridization. Okay. Next question number 17. The hybridization of ethyne, ethene and ethane respectively are. Okay. So we have ethyne here. Okay. Next we have ethene here. Okay. This is ethene. And next I have ethane. Okay. Ethane. Okay. Now if you see here, I have for each carbon 1, 2 sigma bonds, right? 2 sigma bond means sp hybridization, right? So we have these two options, eliminate these two. Next in ethene, if you see 1, 2, 3 sigma bonds are there, that means sp2 hybridization. Okay, so after sp it should be sp2, sp2. Then if you see here we have 4 sigma bonds, so it is sp3 hybridization. So that is why correct answer is option number A. Okay. Next question number 18 is from Comet K 2021 question. Which of the following represents zero overlap? So if you remember, for overlapping, for sigma bond we have 3 types of overlapping. One is your SS, another is SP, another is PZ, PZ, right? And for pi we have PX, 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 PX or PY, PY. Okay, so here you can see it is S and PZ. Yes, the S and PZ is possible, that is sigma bond, this is correct. Then you have PX, PX, this is also correct. Okay, next if you see here PX, PX is also combining, but this is destructive interference, so this is also correct. But here if you see S and PX, S and PX will have zero overlapping because S and PX do not have any symmetry. So that is why the correct answer here will be option number D. Okay. Next question number 19. A molecule is square planar with no lone pair. What type of hybridization is associated with it? Okay. So square planar with lone pair. Now see, square planar can be in 2 categories. One is with sp3d2, okay, where you have 4 bond pairs and 2 lone pairs. Or it can be in the case of dsp2 hybridization, where you have 4 bond pairs and 0 lone pairs. And in the question it is showing that it is 0 lone pair, so the hybridization has to be dsp2. Okay, why it is not sp3d2? Because sp3d2 will come with this one, 4 bond pairs and 2 lone pairs. Okay, so question was asked in 2019, comment K. Next question number 20 is about your MOT. Which of the following statement is incorrect? 2023 question, bond length, bond order questions have been asked. So first let us see the species that are given: O2, O2 2 plus and O2 2 minus, right? So I have O2, O2 2 plus and O2 2 minus, right? So now if you see, O2 is how much, just if I calculate 14, 13, 12, 11 and 10 and 15, 16, 17 and 18. So 14 is 3, this is 2.5, this is 2, this is 1.5 and this is 1, and this is again 2.5, 2, 1.5 and 1. Okay, so now O2 is 16, right? For 16, what is the bond order here? So 16, the bond order is 2. And O2 2 plus, 8 plus 8 16, minus 2 14, so 14 is bond order is 3. And here 8 plus 8 16, 17, 18, 18 bond order is 1. Okay, so now if you see what is bond order, so first it is O2 2 plus, then it is O2 and then it is O2 2 minus. Okay, and then bond length will be what? O2 2 minus, O2 and O2 2 plus. Okay, this is the order. Now let us compare the options. Bond length of O2. Question is given, bond length of O2 is greater than bond length of O2 2 plus. Yes, this is a correct statement. Next, bond order of O2 plus. Okay, so this is actually O2 2 plus. Okay, bond order of O2 2 plus is less than the bond order of O2 2 minus. No, this is incorrect, right? Because we can see that the bond order of O2 2 plus is greater than O2 2 minus. So this is the incorrect statement, option number B here. Okay. Next, question number 21. I have to tell the stability of the species Li2, Li2 minus and Li2 plus increases in the order. Okay. So if I see now, we have Li2, okay, Li2 minus and Li2 plus. Okay. Now if you see Li2 has total valence electron of 6, right? So we can just write down their configuration. Li2 is 6 electrons are there, so we have sigma 1s2 and sigma star 1s2 and sigma 2s2. Okay, so now what is bond order formula? Bond order formula is half into number of bonding electrons, 2, 2, 4, 4 minus 2, so that is 1. Okay, so I got Li2 bond order is 1. Then we have Li2 minus. Okay, so Li2 minus will have how many electrons? 6 plus 6 plus 1, 7 electrons will be there. So if I calculate here, sigma 1s2, okay, sigma star 1s2, sigma 2s2 and sigma star 2s1. Now if I want to calculate the bond order here, it is half of bonding electrons 2, 2, that is 4, and here it is 3, so 4 minus 3, right? So 4 minus 3, 1 by 2 is 0.5. Then we have Li2 plus. Okay, Li2 plus is what? We have sigma 1s2, sigma star 1s2 and sigma 2s1. Okay, so now if you see, if you want to calculate the bond order here, you will get same thing. Bond order will be half into number of electrons in the bonding orbital, that is 2 plus 1 3 minus 2 by 1. Okay, that is again 0.5. Okay, so one thing which is clear out of this is Li2 will be the having the highest bond order, right? So you can see only one option is having Li2 highest bond order, so option number C will be the correct answer. And when you get the same bond order, the one with the positive charge will have more bond order, okay? So that is why option number C. Why? Because you can see here, in case of Li2 minus, the electrons are there in the anti-bonding orbital, okay, which is unstable, and in case of this one, the electrons are present in the bonding molecular orbital, which is stable, okay? So that is why option number C. Okay, next question, arrange the following in the increasing order of their bond order. Again, O2, this one is there, so we can do this one. We remember 14, 13, 12, 11, 10, and we have this side 15, 16, 17 and 18. And if I want to write the bond order, 3, 2.5, 2, 1.5, 1, 2.5, 2, 1.5 and 1, okay? So now if I want to calculate for O2 2 minus, okay, O2 2 minus, so that is 8 plus 8, 16, 17, 18, that is your 1, okay. Next we have O2 minus, 17 is 1.5, okay. O2 plus is 15, that is 2.5, okay, and we have O2 16, that is 2, okay. So now if I want to see O2 plus bond order is highest, right, you need to calculate in the increasing order, means the lowest one. O2 minus should be at the end. You can see only one option, these two options, we can eliminate these two, and the highest one should be O2 plus, right, and we have only one option with O2 plus highest, option number D has to be the correct answer, okay. I hope students you all are doing it correct. Next question number 23. Consider the following statements. Bond length in N2 plus is 0.0. So we have N2 plus, N2 and NO plus, NO, O2 minus, okay. We need to compare these statements individually. So let us first think N2, okay. So N2 is having 14, bond order is 3, right. N2 plus is having 13 and bond order is 2.5, right. So now what I can say is bond order is N2 is greater than N2 plus, and bond length if I talk, that means N2 plus is greater than N2, okay. Now in the statement, bond length in N2 plus is 0.02 angstrom greater than N2. So we need not think about these number, we need to think whether it is greater or not. Yes, it is greater, so this statement can be correct, right. Now let me erase this one and go to the second point, that is about oxygen, right. So that is about NO, okay. So if you see NO, yeah, so NO is having 7 plus 8, 15, 15 means again 2.5, okay, and NO plus will be having 14, that is 3, right. So I can say that bond order is again NO plus is greater than NO, okay, and in bond length will be NO greater than NO plus, right. So this bond length in NO plus is 0.09 less than that of NO. So that less than is correct. You can see bond length of NO plus is less than the NO. So that is why this statement is also correct, okay. Next, if you see O2 2 minus has a shorter bond length than O2. So if you see O2 is 16, right, O2 is 16 and its bond order if we check, it is 2, okay, and O2 2 minus is 18 and its bond order is 1, right. So now if I see bond order of O2 is greater than O2 2 minus, so bond length will be O2 2 minus greater than O2, okay. So now if I see here O2 2 minus has a shorter bond length. No, O2 2 minus has a longer bond length than O2. So that is why this statement is also incorrect. So we have only 1 and 2 statement correct, that is option number C here, okay. Next question number 24, in a homonuclear molecule, which of the following set of orbitals are degenerate? So if you remember, pi 2px and pi 2py are degenerate, option number B. This is Comet K 2022 question, simple and easy. Next, the relation between the dissociation of energy of N2 and N2 plus. So if you just see now, N2 bond order is 3 and this is 2.5, right? So that means N2 is a stronger, bond order is more, that means bond strength is more, that means bond enthalpy will be more, right? So the dissociation energy are equal for both? No. Dissociation energy of N2 can either be higher or lower? No. Dissociation energy of N2 plus is greater? No. Dissociation energy of N2 plus is greater than, okay, these two options are same, right? Yeah, so we can make it any one option like this. Okay, this may be incorrect. Is less than the dissociation energy of N2, 2019 question. This is correct, option number D here. Okay, I'll check these options, but yes, the point here is the dissociation energy of N2 will be greater than the dissociation energy of N2 plus. Okay, next is question number 26. This was the question which I left at that time. Okay, we are discussing now. Which of these represents the correct order of their increasing bond order? Okay, increasing bond order you need to find out. Okay, so now let us try this question. First of all, we can decide between O2 plus and O2 minus. So O2 plus is your 15, okay, and O2 minus, okay, 16 plus 1, 17, right? 16 minus 1, 15, 16 plus 1, 17. So now if I have 14, 15, 16 and 17, so this is 3, 2.5, 2 and 1.5. Okay, now this one is 1.5 and this one O2 plus is 2.5. Okay, so I can say that O2 plus will be more than O2 minus. So whichever options O2 plus, so this we can eliminate. Here we have O2 minus greater than O2 plus, we can eliminate. Here and here we can think about these two. Okay, next if I see carbon 12, carbon 2 minus, so 6, 12, 13, 14, that is 3, right? C2 minus, so it is carbon is 6 plus 6, 12, 13, 14, and for 14 it is 3, so definitely carbon 2 minus will be highest. So that is in option number B is the correct answer. Okay, next, which of these following represent the correct order of their increasing? Okay, this was the same question, option number B. Next, hydrogen bonding question. Which of the following is an incorrect statement? Hydrogen bonding is stronger than dispersion force. Yes, correct statement. Sigma bonds are stronger than pi bonds. This is also correct because of in sigma bonding we have head-on overlapping and on pi we have lateral overlapping. Then ionic bonding is non-directional. Okay, this is also correct. And then we have sigma electrons are referred to as mobile electrons. This is incorrect because pi electrons are referred to as mobile electrons because they are loosely bonded, right? The correct answer here will be option number D. You need to find the incorrect statement. Okay, next, the correct order of boiling point in the following compounds is. So boiling point order, if you want to find out, you know, water has 2,2 hydrogen bonding, that is why it has a very high boiling point. The correct answer for this question will be option number B. Okay, and the last question here, the intermolecular hydrogen bonding is present in. Okay, so this is intermolecular hydrogen bond, KCET 2018 question. So if you see, intermolecular is present in para-nitrophenol and in ortho-nitrophenol it is intramolecular. Okay, the correct answer for this question will be option number C. Okay, then one more question is here, the melting point of ortho-hydroxybenzaldehyde is lower than the para-hydroxybenzaldehyde because of, so melting point of ortho-hydroxybenzaldehyde we get intramolecular hydrogen bonding, and in case of para-hydroxybenzaldehyde we get intermolecular hydrogen bonding. Okay, so that is why the answer is here. Ortho-hydroxybenzaldehyde has intramolecular hydrogen bonding and para-hydroxybenzaldehyde has intermolecular hydrogen bonding. Option number D is the correct answer. Okay, this was 2017 Comet K question. Okay, now after doing these questions, what I have analyzed, you can see here that these are the different topics that is present. Okay, from Lewis structure you can expect one question, formal charge one question, ionic bond one question, Fajan rule 1 to 2 question was there, dipole moment 2 question, bond parameters you can see 3 questions, VSEPR theory 4 questions, hybridization 5 questions, MOT 8 questions, and hydrogen bonding 4 questions. So in case you are skipping this topic, or at the last moment you want to cover the important topics, then you must focus on these topics, that is bond parameters, VSEPR theory, hybridization, MOT, and hydrogen bonding. Okay, so yes students, these were the top 30 questions from this chapter, chemical bonding and molecular structure. So if you have any doubt in any question, you can comment down, I'll definitely address, and please subscribe the channel and see you soon in the next class.